Let him introduce us to Meshtastic. I am super excited.
All right, thank you, Joe. Thank you, Adam, for having me. Like I said, my name's Ryan Turner, A0RET. It's been many years since I've been here. Thanks for having me back, even though I'm a little bit of a stranger. I started in front of you. We'll see a TV or a T-Jack already. The trackball and it's powered on. Feel free to play along. Play around with it. You've got another one that's kind of passing around the room from this side too. So feel free to tinker with some of the devices as I go through these slides here for the next 20, 30 minutes or so. And then we'll have question and answer at the end as well as maybe some more hands-on demos too. So some of y'all might already be familiar with Meshtastic, but just to make sure that we're on the same page, Meshtastic is a project that enables you to use inexpensive LoRa radios as a long-range off-grid communications platform. Now, what that means in practice, essentially, is you've got a lot of these devices that are less than 1 watt, typically battery-powered, and they form what's called a mesh. And it's useful to send data communication really slow. We're talking about kilobits per second worth of data. So you're not going to do voice over this. You're not going to send a picture or any of that type of stuff. But you can use it for basic messaging. And there's some experimental things you can do with it beyond that. When you think about Meshtastic, think about it for sending messages as well as maybe some encoded data type of packets too. I'll get into that in a little bit. But Meshtastic off-grid, what does it mean? Well, this is a project that's really built around the original premise of a couple of folks who went hiking together and said, we're going to be outside of cell coverage. I don't want to carry around an HT. I want to be able to send you a text message if I'm not there right beside you, and I don't want you to have to fumble with your bag and pull out a speaker mic or whatever. Nothing I'm going to tell you is not urgent, but I'd like to be able to send you a text even though I don't have cell and I don't want to carry around with me a little satellite text device like that. So anyway, that's kind of the original idea that this was born out of. What if we could do kind of this ad hoc data networking for the purposes of text messaging? And the project's grown since then. So I mentioned before what you can do with it. Primarily the use case of Meshtastic is to send text messages. But at the end of the day, it's just another way to transmit data. So realistically, you can also use it to collect sensor data. And that's actually the underlying tech here. I mentioned LoRa. I'll get into that in a little bit. That's actually more the standard use case for LoRa. So folks who have come across that maybe in some industry, maybe you happen to work in, say, public service, a smart city grid infrastructure type stuff, or maybe you're in agriculture and you might have distributed sensors across your farmland to detect soil conditions. LoRa's bread and butter really originally is around collecting sensor data. Now, additionally, since we've got these devices that just kind of repeat information that they hear, this mesh, that might make your ears peak up a little bit, and all of a sudden you say, that sounds a lot like APRS. And you can use it for some of the same purposes like tracking location data. Now, I mentioned before that this is really low-powered stuff, 1 watt. Don't underestimate the capabilities, though, of LoRa itself. Right now, the world record for Meshtastic, and it's really hard to see here. Sorry, I didn't make this very easy on you. More than 300 kilometers range between 2 devices. Let's talk about how they achieve that. So LoRa in and of itself is a mode that can reach into negative signal-to-noise ratios. So that means that it's kind of like some of those voodoo HF modes where you don't see the signal there in the waterfall. You certainly don't hear anything with your ear, but somehow it's able to pick that out. That's all LoRa in and of itself. Now, by convention here in the United States and in a lot of the world too, when people talk about Meshtastic, what they really mean is Meshtastic running on these devices that are on the 915 megahertz ISM band. So, by definition, for the folks who played above 7 centimeters, you know, that means you're into what's called near line of sight territory. So that 300 kilometers I talked about. The only reason that's possible is because they've got a mountain on each end, and then there's a waterway in between. You're never going to see that here. Probably never see that in your life if you end up playing with Meshtastic, to be honest with you. But even though it's near line of sight, it doesn't go all the way up to what you might interact with if you've got, say, 2.4 gigahertz experience or even higher than that, true line of sight. 900 is kind of this in-between state. If you've played with it for, say, voice, you know it does have the ability to penetrate buildings. After all, this is darn close to what all of our public safety radio systems use in the upper 800 megahertz. So we know it can go through trees and most building walls and vehicles sometimes. So realistically, near line of sight, and we've got two of these devices here in Memphis where it's pretty flat, and we're not in a Faraday cage worth of a building, you might be able to get a couple miles between those devices. But I'll talk a little bit more later about where we can extend that range some. Now, another thing that's noteworthy about being 915 megahertz ISM is that means it's unlicensed spectrum. It might be tempting to go and use your ham radio license here as you use these devices. The spectrum's coincident. You can choose to throw your license against it. But we don't necessarily need it, given the link budget that I talked about before. The restrictions of ISM, where you can get up just above a watt, that really is enough. And there's some benefits with this project to using ISM, where you might be able to interface with people who don't have a ham radio license on the other side. Or maybe you want to be able to communicate with a bit more privacy than you come to expect with, say, sending an APRS text message. And if anybody's played with that, you know one of the disclaimers is, the whole world just saw your text message. I've talked about all these different angles of Meshtastic so far. You're probably still sitting there saying, well, what is it? Meshtastic as a project, that name project, the trademark for the group. It's essentially four different things altogether. It's a group of people building open source and free software and hardware in most cases, and they're focusing in these four areas. First, primarily the project is building firmware for embedded devices. So think about what it's kind of like if you program an Arduino. You all talked about Arduinos a little bit tonight. That's what we're talking about. A group building software to run on microcontrollers, that's kind of like that. Additionally, Meshtastic is a set of standards and APIs. So while it's leveraging LoRa, and LoRa by definition means you've got kind of 4 or 5 parameters to tweak, and then past that it's just LoRa. It's kind of like FM. Maybe you talk about the bandwidth of your FM, but to most people it's either narrow or wide, and that's it. You got that one parameter. Same kind of thing. So they got some standards for LoRa on top of that specify how it performs. Sometimes you might prefer ways to send more data through if you've got devices that are closer together. Sometimes if you're more spread out, you might use one of their presets or standards that's for trying to maximize range at the cost of bandwidth and throughput. The other thing is it's a project that's building a set of APIs. So let's talk about that firmware. The radio is only as good as the thing that you can do with it. Once again, anybody who's played with an Arduino knows, well, until you get a user interface there, there's not much value to that thing. So the APIs are what come out the other side of the device and then interact with the third component of their system, the end user interfaces. So as most people think about Meshtastic, they think about maybe one of the devices I have on the table here, or maybe the TDEC devices that I'm passing around. But the thing you put your hands on ends up in most cases being a mobile app. They've also got an end-user interface that's a web app that you can use too. But in general, that's kind of the third primary component of the tech ecosystem that makes up Meshtastic. They've got different people in the community who are focusing in different areas. I'm a contributor who's helped with some of the web portions of things. There are other people actually pretty nearby. I don't think there's any other folks building Meshtastic locally. And I can't really claim to. I just made one small change. But there's one of the key founders, or maybe it's better to call them key contributors to Meshtastic that's actually based out of Little Rock, and he's a ham too. So there's people around us who are helping build Meshtastic as a platform, in addition to helping people like y'all join the network, get in, learn how to use it, maybe put your hands and tinker with some of the hardware too. And that's kind of the fourth bullet point that I'm talking about. Is Meshtastic in practice really is a community of people who are interested either as users or as makers, tinkers, radio enthusiasts who want to explore some of the applications, or maybe actually directly contribute to the way it in and of itself is built. Now, once again, go back to some use cases. In practice, I kind of teased it. That wasn't really a great what is it. I drew a comparison before to APRS. You can have a mode for Meshtastic where it's a tracker. The little device that I have over here, sorry for the delay, this is called a TDEC. This is a commercial off-the-shelf available device. You can buy it from Amazon. You can buy it from a couple different sources. And it's interesting in that it's a Meshtastic radio. It's meant to be paired with your phone and for you to really use your phone to send and read messages and things. But it's got a battery built into the back here. And in the top, it's got a GPS receiver. So it can also serve as a standalone tracker too. Now this might sound kind of familiar. This might then kind of once again to use that parallel to APRS, kind of get you closer to some of those APRS devices where maybe they got built-in GPS, but maybe you can also connect to it and have your phone be the TNC with some of those mobile apps. This device is kind of similar to that. Now, Meshtastic being this kind of open source community project, there are lots of folks who built other hardware besides this. So don't think this is the only option for tracking. And actually, in the case in my truck, I've got a Meshtastic radio that's built to serve this tracker role too. And it's a completely different hardware platform. Most of the hardware, by the way, that makes up Meshtastic, I talked about how LoRa had those smart city grid infrastructure uses, agriculture uses. A lot of the hardware that they're built on are actually platforms made for electronics companies to develop those types of sensors. They're evaluation boards. It's kind of like, once again, an Arduino, or maybe you've heard of an ESP32 and the dev kits that exist in that realm. That's what a lot of these platforms actually use as their key thing. It's the microcontroller, it's the transceiver chip, maybe it's even battery management and being able to manage a solar charge too. So, this example is where for my QTH, not too far from Bartlett, on my rooftop I have a receiver. There's another node within the 240 loop that heard some of this traffic. This blue dot that moved around the map was somebody else who chose to share with the local Meshtastic mesh their location. And they chose to set up to automate sending their location. They used that tracker role that I talked about a little bit. And so in many ways, the service of it becomes pretty similar to if you had an APRS tracker on your car. But there are a lot of differences. I keep making this comparison to APRS, and I think it's a little bit unfair, so let me go into some of those things. Meshtastic and LoRa in and of itself is really energy efficient. Most devices look like this or smaller. The TDEC that's being passed around the room. That's kind of a combination of one of these and a user interface together. It's got a touch screen, it's got a keyboard, it has its own user interface built in. And that runs on a battery. Its RF performance is about the same as this one, which is about the same as the node that was on my roof that I was using to receive that other traffic. The protocols, the software, the firmware, it's all really energy efficient. And so that, once again, going back to that idea of ISM is really enough. You don't need an amplifier. You don't want to push 50 watts through this. It's because it's really energy efficient. And thanks to that, and thanks to some well-optimized firmware tricks and using some nice microcontroller platforms, you can make it where a node actually carrying traffic, doing stuff, can last days on a small battery. And small, I mean like a little puff cell LiPo battery. So if small to you is tens or hundreds of watt hours, you're probably talking about running for weeks or months at a time on something like that. Because of that, then a lot of people choose that where they do want to put a node high up, they'll make it solar powered. They'll put a small solar panel on it. That's a 12-watt panel. That's actually quite big. That's oversized. Think half that size in most cases. And so some people who choose to deploy these on a tower, maybe up in a tree, they'll just have it be battery powered. They won't even run a cable down to the bottom. It'll just be a standalone thing dangling up in the air. Now, the other thing that's interesting about Meshtastic, because of LoRa and that negative SNR capability I talked about before, it works in really noisy environments. So folks who played the 900 megahertz, especially since smart meters have popped up and other smart tech, 900 is noisy. There is a lot of other stuff. You're competing with every little consumer device. But because this is able to work in those negative SNRs, it actually works in these noisy environments pretty well. Now, Meshtastic is also privacy-minded. Unlike APRS, unlike a lot of other projects that people are familiar with, by default, it starts out assuming you don't want to share your location. And maybe you don't even want to have it where everybody can talk to you. So it's privacy-minded in that sense, where you might have some people join who don't necessarily share the same values or ethos that ham radio operators do. When you go on a repeater and you talk, and you understand, everybody's going to hear you. So in a lot of ways, bottom line, what makes it different is it is kind of like that original intention of being that offline text messaging that they set out to build. So you probably now are wondering, why should I care? Okay, I already do this with APRS, or I already have a cell phone. I think Meshtastic for me is someone who does have a couple APRS nodes and has tinkered with that, sometimes at the cost of impacting some others. I think Meshtastic is a good supplement to APRS, with an emphasis where most everybody on Meshtastic has a keyboard and engine box on the other side. Most of the devices there aren't those passive trackers. And it's also RF first. There's not an emphasis on trying to say, let's link everything together. That's not the goal of their project. And simply put, going back to the performance of this thing, this could not handle if it heard everybody in the world all at once. It can handle 100 different devices at a time. So they really put an emphasis with this project on RF first. They really care about making sure the performance works well, where are the devices that can talk to each other locally, and the idea of an eye gate and forwarding traffic into the internet and back out, it can do that. It's not really built for that. Now, something also to the benefit of this project and the fact that it's using this tech that exists already at scale with these evaluation boards for all those electronics companies. This stuff is affordable. I'll share some slides in a second talking about the prices and availability of things, but these are things sitting in the Amazon warehouse that cost you less than a dinner, that you could get delivered primed to you by Thursday morning. And I talked about all those different components and the fact that it's open source and free. There's a lot of innovation going on around Meshtastic right now. So I think you should care for the reasons that I care. It's cheap. It's something a little different, even though it is familiar. And it's changing pretty aggressively, and that's exciting to see where it goes. So to give you another example, I talked about how really the use case is built around sending text messages. By default, everybody who connects and configures a node shares a common group chat. They just call it kind of the default channel. If you have one of the devices in front of you, you can tap through and you'll see it called, I think, long fast is the name as it appears on the screen. And so by default, you plug it in, they say, hey, I'm in the United States, it reboots, and then all of a sudden, it starts picking up the other devices that it can hear over RF, and you've got this shared group channel that you can send messages out to everybody. Now, you can also configure for group messaging additional channels that are private to you and other people who know your pre-shared key. So think of that kind of like the idea of having a private chat.
you could do that and you could use it. Maybe it's for your family. Maybe you've got a coffee group that wants to talk. Maybe it's not actually so important that it's private to you, but you just don't want to make everybody else's devices buzz when you and your two buddies are talking throughout the day. So you can add other channels, and at the end of the day, they actually all ride over the same RF. And in most cases, they get repeated by all the devices, but they're encrypted. So they don't, the people who are repeating the traffic don't actually know what the message contains. So everybody's got a group chat. And you can add additional ones too if you want to. So I made that parallel before about it being about the price of a dip. The radio itself that I've got here on the table, it's about $30. I'll show two places that you can get them. They come with stock antennas. Like most things in life, the stock antennas aren't that great. So I suggest getting an aftermarket antenna. Now you're up to about $20. If you were to build a node and try to deploy it to get your shack connected to Meshtastic here, because of how flat it is around here, you probably want to put it up on the roof, or maybe throw a line over a tree limb. So at that point, then you need to put it in an enclosure to keep it watertight. And at that point, then you need to figure out either a battery for it, or maybe you do want to run a cable to give it some DC power from the ground, but something there to manage the power. And going back to now how to actually use the thing, it's up there, I'm down here. You connect to the device over Bluetooth. Now, it uses Bluetooth Low Energy in most cases, BLE, which has a pretty darn good range. But sometimes maybe that tree limb in your shack aren't actually close enough for that to work. And so sometimes people like to have one of these devices up in the tree, and then they might use a smaller device down local to where they are. For instance, this is the device I choose to carry. No fancy antenna here. This is not getting out miles, but it can get to my rooftop node, which then can relay my traffic. So I promised a couple of options. This is what a lot of people use as their first node getting into Meshtastic. This is called a whiz block, a rack whiz block. Crazy names. Once again, think of an industry application for a completely different thing that just happens to work for this project too. There are domestic options to source this. You can also get it from Amazon directly. This vendor online had it for $31.97. Another popular option for people to get connected for the first time is a HealthTech V3. Once again, crazy names. This is an option that's available on Amazon. It's about $26. The price fluctuates a little bit based off of Amazon's pricing. It comes with a very terrible antenna, the way to get started. And it comes with these pins and all these cables and everything. You don't have to worry about that. There's no soldering involved. You plug in a USB-C cable, that's how it gets its power, you're up and running. So my title slide said Meshtastic for Memphis hams. Let's talk about Memphis. Right now on the network, we've got about 30 devices that are actually able to connect to the mesh in and around here. And those are spread across about 15 feet. Some of the things on the map here are this lighter blue that indicates a node that was there and maybe went away. There's a lot of people who've been playing with this. This isn't a new project. Meshtastic's been out there for years at this point. So I imagine a lot of people have devices sitting in the drawer somewhere, and they don't realize that more people have them, and this mesh is actually starting to fill in. Another thing is, since so many of these devices are battery powered, devices come and go, and that's okay. So the solid blue represent nodes that are connected to mains power. So things that are reliably up and contributing to the mesh. You can think of it kind of as though if you're within a decent range of there, you could probably get to them, and then they can carry your traffic into the rest of it. Something interesting happens too, where at times, if you had a map looking at this, and there are some options online where you can view the online version of this, because we do share the data with an online aggregator. Some knucklehead will bring one of these devices on an airplane and go flying over at 30,000 feet, and line of sight all of a sudden means something very different. And all of a sudden at that point, we're talking to people in Birmingham. We're talking to people all around the far side of Arkansas. Wow. Another thing that's exciting is some mornings you wake up and there's tropo. You'll probably see that in some of your ham radio. Maybe UHF, maybe you do tinker up in 900. That applies here too. Tropo has made it in the past, or we've been able to send messages back and forth to the group in Little Rock and to the folks in Middle Tennessee and Birmingham. So about 30 devices between about 15 users. But what I found is if you leave a device plugged in and kind of listening, you might come back in a couple weeks and all of a sudden see, whoa, where did all of a sudden these other folks pop in from? There might have been a small opening, and then all of a sudden there was a window of time where you could have messaged them. So between those 15 of us who are connected into Meshtastic right now, there's a couple things you can do besides send each other hello ping messages. I talked about the API, that ecosystem of things that exists around kind of peripheral Meshtastic. Well, right now the traffic is gated online, and so you can get to see the map of where different devices are through a website called MeshMap. And so all of a sudden from there, you might be able to say, okay, I'll make my tracker public, and they'll tick the box that says I wish to share this with the internet, because you get that control on your device. So you get to opt in. And then at that point, you might send your family member a link and say, hey, here's my Meshtastic position tracker. That's one potential application. Additionally, on the network, there is a bulletin board system. So there's a node set up with a bot, and when you message it, it actually replies back very similar to what a BBS that you might have interacted with through a modem in the past is like. Similar kind of bot user, but kind of on the other end of the spectrum. There's another device on the network that is connected to a number of little scripts that aggregate different data sources. So we have it where anytime there's a NOAA weather alert, it sends a message out, including the text content of that alert. I imagine each of you can get those alerts in about 50 different ways, but probably not that exciting. But that same device then, too, can do things like Google search or look things up on Wikipedia. And I've even got AI large language model running on it. And so if you wanted to ask it to write you a haiku about what you should eat for breakfast tomorrow, in about 2 minutes it'll reply back. It's a little Raspberry Pi, so it doesn't have much computing power. But so there's all sorts of weird things you can do with it. Those are some of my weird things I've done with it so far. So if you do get a device connected to it, you might find that if you send certain messages, you'll get some wacky responses back, and that might be one of the bots. At the end of the day, Meshtastic, though, the use case is talking to other people. And so there's about 15 of us you can talk to right now. I'm really hopeful that some of you tonight might be compelled to join us. Now, showing what the actual application looks like. What's the user interface for this? This is what the iOS app looks like. Essentially, the main screen people interact with is a list of other devices that you've seen. They refer to those as nodes. Each of these radios is a node. And so from here, you can see what's its position relative to you, if they choose to share that. You can see when you last heard that device send any traffic at all. You can see your signal level, if you use the device directly. And from here, it'd also be where you'd send them a direct message. If you want to send them just a one-to-one message as well. So let me show you a couple of these devices in application, and then my presentation's over, and we can do Q&A. Last month, the Tipton Amateur Radio Society got together, and there was a presentation there about Meshtastic. And one of their members, Bill, is an adopter of Meshtastic up there. So he shared this experience, and I'm recycling the next couple slides from him. Bill at his QTH outside on a pole has a solar powered node. Now, that's a couple hundred feet away from his shop, which he uses as his shack. And so it's a metal building. His little device like this doesn't get into that thing down the driveway on the pole. And so he's got a second device inside his shop. The one on the pole, though, looks like this. It's a little enclosure that you go and buy over at a big box hardware store. It's a LiPo battery cell. And then it's the first of those boards that I showed you back when I gave you two options. It's a rack whiz block device. And so this in and of itself, with the way that he's got it built, up at the very top there, and I guess this is where the laser plug is there, is going to come in handy. This is a little Bluetooth antenna, so that way he can connect to it. He can walk over to it and configure it if he needs to. Maybe he needs to change a setting on it. He doesn't have to take the whole thing down. He can connect to it from underneath the pole. This is his coax. it's 900. You're going to use SMA connectors, just like what you use for Wi-Fi, basically. Not RP. Not RP SMA. Don't make that mistake. And then, since this photo, I believe he added a solar panel to the actual cover of this and wired that into the whiz block. The whiz block not only has this battery jack, but then there's a second one that's used as a solar panel input. And so here's what his device looks like on the top of mast. That's the solar panel. That's the actual box with the enclosure with the battery and the radio. And then he's got an antenna off the top of it that you can't really see from the picture. Here's another example of a similar type setup. This time it's off of a tree. This is at my house. Very similar. Little gray plastic PVC box from the big box hardware store. An antenna up at the top. It's got a battery inside. Right now, I actually don't have a solar panel hooked up to it. This device runs for about 3 or 4 days on a charge. By that time, I expect it's going to get blown out of this tree anyway, so I'm probably going to lower it and recharge it just off of my little USB-C jack. Maybe one day I'll add a solar panel. But this is just me with a little arborist throw bag and a 75-foot yellow throw line. Tossed it up in a tree and hoisted it up. There I go. I got it. It's about 70 feet, and that's where I lied. I didn't toss it. I used a launcher. I don't have that kind of arm. On the inside, we've got a different type of device, but once again, they're all kind of commodity. It's all kind of the same. Here I chose to use something called a Heltec T114. Doesn't really matter. Ignore that point. It's another radio. This helps me get into the mesh with my local nodes, like the one that I've got here on my belt. Now, I talked about some of the fixed devices. These are the things at the QTH. I got some other stuff on the table here that looks a bit different, though. I'm going to refer to those as infrastructure nodes, though I'm kind of just making up that distinction. It doesn't really exist. Essentially, there are 2 Meshtastic nodes today that are on rooftops up high. One of them is in East Memphis. If you do connect to the network, you'll see it called Eastern Tall Poplar. Just a silly name, whatever. Another one on the edge of Midtown and downtown called Medical District. So those are devices that have a little more oomph to them. They've got cavity filters. They've got a small amplifier. They have a low noise amplifier preamp for the receive side. They're built to be managed remotely using a little local Linux computer. So you can imagine, I don't want to go up there and hold my phone out, connect the Bluetooth anytime I need to change the setting or something like that. So they're a little bit different. And they contend with some different noise parameters too, because if you're familiar with what it looks like a couple hundred feet up from an RF perspective here, these sites are fighting with Memphis-Shelby County's integrated public safety radio system. They're fighting with hospital paging. Yeah, they're not actually, those aren't in 900 megahertz, but they're adjacent on either side. And it sure does punch out a couple hundred watts, which these little evaluation boards aren't so happy about, being able to see a quarter mile away by the naked eye. To give you an example of those look like deployed, and I know what you're going to say, I need to push this up, I couldn't get there, I know the pattern's not right, forgive me, didn't have a leg. Big antenna, it's got about 10 dB a gain, it's not really that important for rooftop nodes, but trying to squeeze every little bit of that performance out where I can in those couple of spots. Here's another example of the node that's over in the medical district. Once again, very similar pattern. This time it's a 6x6 electrical box. It's got a slightly different antenna. It's mounted on an arm. So hopefully the battery's a little bit better compared to the last one I showed. But we've got a couple of these infrastructure devices, and their whole goal is to try to have a little bit more punch to make it where those rooftop devices don't have to have a neighbor, one neighborhood over, and have that be the one person you can talk to. The goal here is to try to make it where we can help build out an initial mesh as the rest of it gets filled in. So how do these form a mesh? I kind of glossed over the whole idea of how does the routing work? How does the network work? These highest up nodes, those 2 that I just shared, they repeat everything they see. They're configured with a role called router. And it basically just means that they're going to guarantee they're not going to do any battery optimization. They're not going to be very polite either. They're just going to opportunistically repeat everything that they hear. Now, those 2 nodes that I showed as the QTH nodes up in the tree on the pole, those play a role called client. And what that behavior is it repeats any packet that it hears that hasn't been repeated a second time. If you're in the networking realm, this is what's called a flooded mesh network routing topology. And so essentially it helps extend the range of the network, but you don't create a scenario where everybody's repeating everything by default and just using up all the airtime. Now, these smaller devices, like the one that's been passing around or the one on my belt, they don't have the chance to provide any range to other devices, so they don't repeat traffic. They use a role called client mute. I can originate traffic, I can send stuff, and if I was feeling kind of hairy, I could go ahead and make it where it repeated everything. That's in my control. But I don't need to, because that just unnecessarily clogs it. No one else is going to hear the traffic repeated here. So that's how it works in a nutshell. And I've blitzed through a couple options of hardware. I've talked about what the network looks like here locally. Hopefully I've also managed some expectations in terms of what you can and can't do with it here right now. At this point, I'm sure there's some questions out there. So I'm happy to jump into Q&A. And other than that, I'm happy to see where are those two devices that are being passed around? Who one's over there?
One device.
Clever. Okay, if you press the trackball, it should turn the screen on. And then at that point, on the left-hand side to scroll through, you should be able, it's a touch screen too, you can tap. You should be able to then find where it's got a icon that looks kind of like a chat. I'll probably have to run over there and help. But what I'll do here is from my device, it looks like people have already actually messaged me. So there's some people here in the room who know the UI. So I've got some messages here during the presentation. But here, for the folks who have it, this is a test. Okay, so devices received it because it went off. Now from there, you should be able to tap in and send a reply. Feel free to pass them around and continue to get your hands on and think about it.
Did that go over Bluetooth or did that go over the Meshtastic?
That was over Meshtastic. So I used my phone to connect to this device.
Okay.
And then this one sent that 900 megahertz LoRa packet, which then those two devices received. And then that noise was the user interface saying, hey, I got a new message for you. And it popped up on the screen there for them to be able to look at. So I'm using Bluetooth here. But after that, it's all Meshtastic. Yes, sir.
Do you have to register or coordinate with somebody?
Nope, nothing like that at all. LoRa in and of itself is not only very good about noise, but also the 900 megahertz ISM is pretty wide, and LoRa is actually pretty narrow too. And so there's no formal coordination. And theoretically, you could get some jerk show up here and spam, use one of those scripts and spam a bunch of messages on there. But there's more than 100 different channels you could run to next. You and your friends could go and say, for our mesh, I'm going to move to this other frequency. And you can do that. Absolutely. And there's other parameters you can tune to.
Yeah, I can say yeah.
Okay. But no registration, no pre-coordination. That's one thing there, the privacy angle.
Keep walking around with that 900 megahertz in the front, you already have no more kids.
So, what's the East Memphis channel repeater?
That's over on the Hilton Hotel. Yes, sir.
So, how does the mesh figure out which one of the channels that you're using, or does it?
So, channel is kind of an overlooked term. When you say that, what do you mean?
How does it find out what frequency it's using within the ISM band?
Yeah, absolutely. So, part of the standards that Meshtastic as a standards group came up with is saying we're going to slice the 900 spectrum up into these predefined frequencies, and that's just arbitrary. That's just what they choose. And then they've also defined within that the rest of the LoRa parameters. I won't go into the nuance there because it doesn't matter much, but essentially they've got presets. Those might sound kind of familiar to like what FRS channels are, where, hey, I'm on 3. Here, the default is what we use. So we're using the long fast preset on channel 1, which just happens to be the settings that you get if you power on a device for the first time and say, I'm in the United States. So that's what we're using, is just the default.
Who's the person in East Memphis that's to the east of the Hilton?
That's Cliff, NS4B. And there's actually some of the users on the mesh right now who've been totally secretive. They've never told me who they are. I've talked to them. They don't really want to talk to me. They'll acknowledge me, but depending on the node, I might not actually know the answer. Yeah, absolutely. Yeah. Yes, sir.
You mentioned different types of sensors. What are some examples? Could you, like, for a personal burglar alarm?
Absolutely. So over at the TARS presentation, a gentleman asked, hey, I have a very long driveway and I don't have the ability to get Wi-Fi down there, even with like a really high-powered point-to-point link. And I don't have any data communication down there. Could I use something like a pressure cell or a IR tripwire for this and have it where this sends me a message whenever that sensor is tripped? And the answer is absolutely yes. So one of the modes that this has makes it where you can pre-configure it to say, I talked about those extra pins that you don't care about. Sounds like you might care about them. And all of a sudden you can plug in a sensor and say, if these 2 pins close, send me a message. And it can do that. Yes, sir.
Is the medical center SCO?
Yes, sir.
I thought right now.
Yeah, pretty identifiable facade, for sure. Sir.
Did you say there was some encryption involved?
Yes, everything is encrypted by default, but because every device comes with a pre-configured group channel, that's an open secret. Everybody knows the password to that. Well, we can go in there and say, I'm going to create a channel number 2, and this is where I said channel was an overloaded term, Joe. In this case, channel means like a group chat. I could say I want to make a group chat, and I'm going to call it you and me, and our password's 123. And I'm going to tell you that out of band. I'm going to whisper that in your ear, put it on a piece of paper. And then if you configure your radio with that, and I configure mine with that, only you and I can decode those packets. And everybody else's device is going to repeat them, but they won't see anything pop up on their device. They don't know what it is, but they will continue to pass the message along until you passively receive it and decrypt it and make sense of it. And that's kind of how direct messaging works too, where you do a key exchange on an automated basis. Every time a Meshtastic device discovers another one, they do a secure key exchange. It's very similar to how public key cryptography works for SSL on the internet, for browsing the web. But each device has its own private and public key pair that's dynamically generated when it runs for the first time. And that's been used to also manage the encryption for direct messages. Some people use this if you're kind of more prepper mindset or maybe search and rescue. You might be familiar with a platform called TAC or ATAC. This is compatible with ATAC. On Android and iOS, you can sideload the app for this alongside TAC, and it can use this as the transit for TAC data.
So you can set that encrypted direct up. You don't have to do it on the fly. It just does it anytime you want to go between a couple of different.
Anytime my device hears a new device for the first time, it automatically interrogates and does a private key exchange. And so any device that it's ever heard, it has tried to then establish an encrypted channel with them that can be used for direct messaging. Now, if it's asymmetric and I can hear you, but you can't hear me, that's going to fail. And then it's going to retry again if I send you a message. By default, like if you get a device at your house, within about 30 minutes, you'll have an encrypted communication channel with everybody else who's on the mesh, just automatic.
But you can't designate it just between 1 or 2 or 3 devices. Or can it?
You negotiate a private channel between each device.
From that initial key exchange, can you create your own keys?
Yeah, absolutely. You can rotate keys. You can manage them directly.
Oh, controls over this at all? Keep people from doing thermal?
Most of the controls are built into the firmware itself. And so that's where things like rate limiting, that's where things like trying their best to make sure you don't stumble into using more power than is licensed, than is allowed when you're unlicensed. That's where things like trying to prevent nefarious traffic from trying to interfere with that key exchange when a device has a new discovery and interrogates a new device. But at the end of the day, since it's open source and it's open standards, absolutely you should expect people penetrating this. I think
Well, I'm not
nefarious.
considering that so much more as I'm
Yeah.
considering it's an encrypted communication channel for people to talk on that we might not want them to talk.
Oh yeah, no, people could if you use it for whatever. Absolutely.
Yeah.
Like a Delta Club check or definitely people that got the Delta Club key can get into it.
I know I'm coming up at almost 8:30. Joe, am I good to answer a couple more questions?
We got a couple more questions, and we have to be respectful of our
Okay.
host. And, we'll figure out shortly.
Sure.
Have you played with the license number at all?
Yeah. Then I have some devices that can use more power than are permitted on ISM. So I could benefit from the use case. It gets hairy, to be honest with you. Most of the stuff folks have can't benefit from licensing because they don't have enough power for that. And like I said before, in most use cases, you don't really need more power. You need more height.
Okay.
Getting more power doesn't really help you when the curvature of the earth or that tall building is in the way. So I haven't found it to be that useful. It comes with a lot of drawbacks because then you don't get any of those encrypted modes. And personally, I'm conflicted about it because I don't think the project does a good job right now of managing blended meshes, where you have some users who are in a licensed Part 97 mode and some users who are on an unlicensed ISM mode. It's very easy for traffic to accidentally get bridged between those two users, which personally I interpret the regulations to mean that's a violation for me. So I choose not to use the licensed mode. It just feels like I don't get the full benefits from the software, and I don't really get any more benefits as a user with my hardware either, because I don't need the power. One last question. Yes, sir.
Okay, you talked about the guys in Tipton County playing with it. You guys down here in Memphis are playing with it. Is there anything in between that they can talk together?
We've had a couple of openings happen a few times, but it's not consistent.
Okay, I've got an 80-foot tower in Millington that somebody you want to put a repeater on, or a unit on it.
I'll write your name down. As you see, I've got some devices, so maybe we can arrange that.
My wife won't let me climb anymore, so you'll have to do that.
I got 2 legs and a harness. Okay. Thank you, Joe.
Thank you, Ryan. I appreciate that. He's got some demonstration things that he'll show, but I will take a minute and ask a shameless plug. If everybody would take the QR code that's on the table or on the door and give us some feedback on what you thought about tonight's activities, we sure would appreciate it with that signal report. Just zap the QR and go out the signal report. With that, I would entertain a motion to adjourn. So moved. Got a motion to adjourn made by? Oh, and a second made by? Halo. All right, and second by who seconded?
Okay.
All right, there we go. Who's that? All right, all in favor, please say aye. Aye. Thank you, guys. Ladies and gentlemen. Ryan's still here. Feel free to have a conversation.